Hello. In this short video, I'm going to be reviewing my method of simplifying radicals. Once again, you don't have to use this method if you don't want to. You can use any other method you want. This is just, I wanted to just reiterate how I do it for my class, and let's get started. So let's say we have something like the square root of 54x to the 7th power. Now, what I want to be doing is splitting this up into perfect squares that are multiplied together, and then simplify that. Now, the way I do that, though, is through an analogy that's saying that this radical is like a prison. And inside the prison, there's all these prime numbers being multiplied together. So we got to figure out what prime numbers are being multiplied together. All right, so that's the first thing we're going to do. We're going to do that using a factor tree. So I start by figuring out how many 2's there are being multiplied together in this number. All right, so 54 is 2 times 27. Now there's no more 2's, but there are 3's now. So I'll go up to my next prime number, which is 3. 27 is 3 times 9. And 9 is 3 times 3. Now looking at just the prime numbers, I've got to look at my index as well. My index here is 2. If there's no index shown, the index is automatically known to be 2 because it's square root. So my index is kind of like the security level for the prison. It lets you know how many things have to pair up to try to escape. So in this case, things have to be in groups of 2 because the index is 2. Now, I said pair up, I meant be in a group. So it has to be in a group of 2 in order for one of them to escape. So one escapes, the other one gets shot and does not. The one that escapes makes it to the outside of the radical. All right, the one that doesn't is gone forever. You don't have to worry about that one anymore. So we have a 3 that makes it to the outside. These other two numbers right here do not make it to the outside. They're still on the inside of the prison being multiplied together. Now you'll notice there's also x's in here. There are 7 x's being multiplied together on the inside. So 1, 2, 3, 4, 5, 6, 7. If I do the same thing, pairs of 2, there's a pair of 2, a group of 2, there's a pair. All right, and out of each pair, only one makes it out. There's a total of 3 that make it out. Now, anything that makes it out to the outside, you also multiply together. So that's going to be x cubed. All right, now this one that's left over doesn't make it out. It's still on the inside. Okay, now I still know what 2 times 3 is, so I can still simplify this a little bit better. So we got 3x cubed, square roots of 6x, and that's my final answer for that. And that's my jailbreak method of simplifying radicals. Now, a couple of things about this. All we really did when we did this was we split 54 up into the square root of 6x times the square root of 9x to the 6th. Okay, and then we simplified. Square root of 9 was 3. Square root of x to the 6th is x cubed. And then this doesn't change. Right, it's those properties of radicals that allow us to do that. So this is my final answer right here. Okay, let's do another example with a index other than 2. So let's do the cube root of 120 x to the 7th y. Now in this one, my index is 3, which means instead of pairs, they need to be in groups of 3 in order for one of them to escape. So we got to do the same thing here. So 120, I'm going to start with my 2's as always. Always start with your 2's, and that way they'll line up, and if you go up by 1 each time, it'll put everything together instead of spread out everywhere. So 120 is 2 times 60. 60 is 2 times 30. 30 is 2 times 15. I'm out of 2's, so 15 is 3 times 5. Now looking at this, I'm looking for groups of 3 now. So here's a group of 3. Wow, that's totally not what I expected there. Hold on. Here's a group of 3 right here. There's 3 2's. All right, now in the group of 3, there's 3, so 1 can make it out. So the other 2 get shot. That 1, 2 right there makes it to the outside of the radical. Now, I still leave the same index. The index does not change. It's still the cube root. I had some people get confused right there for some reason, and I don't know why. That part stays the same. The jail is exactly the same. The security is exactly the same. All right, so on the inside, we have 3 times 5, which is 15. And now I got to figure out my variable stuff. So I have 7 x's on the inside. Now, before, there's an easier way to get this 3 and this 1 than drawing out all my x's. Because you can imagine if I have 15 x's, that's going to take a while to draw them all out and circle them and all that mess. So the easy way to do this is to take the index, whatever the index is. In this case right here, remember it was 2. And you divide the exponent on the inside by the index. The whole number amount makes it out. The remainder does not. So for this one, 7 divided by 2 was 3 with a remainder of 1. So 3 make it out, 1 does not. So applying that to this, 7 divided by 3 is 2. So you got x squared on the outside, and the remainder of that is 1, so 1x stays on the inside. So once again, what I did was I divided 7 by 3. 7 divided by 3 is 2, with a remainder of 1. Now there's only one y on the inside, so since there's only one y, none of them can make it out, so it stays on the inside. And that's my answer. Alright, so now the reason why we're talking about radicals right now is because we are currently in a unit about quadratics and polynomials. And one thing that you're going to have to do when you have quadratics and polynomials is you have to simplify radicals in your answers. So let's say we have an equation that looks like this. X squared minus 48 equals 0. Now some of these you'll be able to factor because they'll be the difference of squares, and you can solve it using what we call the zero product property. We haven't talked about that yet in my class for a reason, and that reason is we're just not there yet. So let's cover this part first though. And you won't even have to use dots if you see something like this. So we've got x squared minus 48 is equal to 0. One way to solve this is to get the x squared part by itself. I'm going to add 48 to both sides. And so I get x squared is equal to 48. So now I have to get rid of that squared. Well, the inverse of squaring something is to take the square root of it. And once again, the golden rule of algebra, or as I say the golden rule of algebra, what you do to one side, you have to do to the other. It's just fair. So I can do anything as long as I do it to both sides. So I'm going to square root both sides. Those parts kind of cancel out and leaves me with x on that side. Now the square root of 48 doesn't come out to be a perfect square. It's not a nice whole number. So I have to simplify it. To do that, I make my factor tree. 48 is 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So I circle my pairs. Bang, bang. One out of each pair gets shot. So these two make it out, and they're multiplied on the outside. So 2 times 2 is 4. And then that 3 doesn't make it out. So it's on the inside still. Okay, so that's simplifying radicals again, and a kind of a lead into what we're going to be doing next, which is solving quadratic equations and some other polynomials with other powers. And if we put a cubed here, then the only difference is we take the cube root of both sides. All right, I hope this helps. Have a good one.